Greeting y'all, this is my project on RoboSquirrel. The objective of this project is to build a robot that can climb this pole all the way up and stay at top for a couple of seconds. To begin, we need a plan. How can a robot climb? I brainstormed numerous ideas such as wheel, tracks, gravity hook, jet propulsion, suction drive, and a balloon. After selecting and condensing my options, I developed a Puke matrix. I compared each candidate with the select criteria such as its budget and building complications. Clearly, with only 2 months to complete this project, I chose the simplest option, the rear drive. I CAD'd a prototype assembly. It got the necessary line, battery, switch, motor, gearbox for fitting gear ratio, a wheel to climb, a clamp to store stabilization, and a hook to hang the robot on top of the pole. So, here is my first prototype. It is made of all Legos. It does not have any components such as the FA130 motors. In fact, I didn't want to use these components. It is limited, and I want to save that for the final build. Anyway, so we got all this here. Looking around really quickly. It's directly taken from CAD. It has the battery, the motor, the gearbox here, and the wheel here, the clamp. Um, Obviously here there shouldn't be a lot of gears here. I only put this much because based on this motor, this Lego motor, it spins too fast, and I need to put this much. In the wheel design, it's not gonna have this much. So basically how that works is it goes to you insert a pole, it goes to a little slot here between here, this two here, and then between here, between the wheel and the little stab here. And when you turn on, this wheel spins and it should be able to climb up towards there. In this design, I want to put all the weight, as you can slightly, I want to put all the weight in this side so that it kind of tilts in an angle so that the wheel is hitting pole really well so that when it climb, it's able to like grip on the pole as to climb. After the successful first prototype, I started my final design. I built the battery holder, the gearbox with two FA130 motors, put them together as so, snap switch on top which act like a hook, and lastly the clamp and the wheel. I added a chain between the gearbox and the wheel so that as the motor turn on, the wheel can spin. But there was a problem. The problem lies between the blue 3D printed gear from the gearbox and the gray gear which attached to the train. They want to push each other apart. This means the gray gear refused to be driven by the blue gear. During testing, it made a lot of clacking noise and had to immediately stop it. To fix this, I redesigned the gear. I 3D print a red gear that is twice the size as its original blue gear. That gear is attached to the gearbox and to the chain. Here is the result. Alright, 3, 2, 1. Definitely a lot more smoother.
That looks great. One Mississippi 2, Mississippi 3, Mississippi 4, Mississippi 5, Mississippi 6, 7, Mississippi 8, Mississippi 9, Mississippi 10, Mississippi. Woohoo!
Nice.
It's that.
If I have more time, I would improve on how to make this robot go faster. I would change the material of this robot. I would switch Legos to aluminum. It might sound a little weird at first because Legos have less density than aluminum. However, I only need to use aluminum less. You see, I can't modify this piece. I can't have the exact size, like 1 centimeter more than this, or I can't have where the hole is going. In addition, Legos tend to be way too flexible. In this robot here, I had bunch of support, this long beam here, this beam here. It's too flexible, it tends to bend, and I need a bunch of them just to make this robot sturdy and rigid. Once I switch the material, if possible, I will modify this gearbox. I want to lower the gear ratio a bit more so that it still provides enough torque, but it has enough RPM to go high.